Chemistry is one of the oldest academic disciplines, and its roots lie in man's fascination towards study of structure, composition, and properties of matter and reaction. Chemistry is not only adds great value towards a progressive society but also contributes greatly to other branches of science. In today's class, I'll discuss an easy chapter for NEET, JEE, ICSE, and other state board students to learn. So let's start today's class. Matter can exist in three physical states: solid, liquid, and gas, that we are learning from class 7. One state of matter can be changed to another state by changing the condition of temperature and pressure. When solid is heated to its melting point, the physical state changes to liquid. The thermal energy supplied overcomes the intermolecular force of attraction present in the solid, thus resulting in the melting of solid. When liquid is heated to its boiling point, state changes to gas. When gas are cooled, the physical state changes to liquid. When liquid is cooled to its freezing point, the physical state changes to solid. All this transformation can also be brought by either changing the pressure alone or changing both temperature and pressure. The physical state of matter is due to the presence of different intermolecular force of attraction, such as dipole-dipole interaction, dipole-induced dipole interaction, London force, and hydrogen bonding. All these four kinds of intermolecular force of attraction already we have learned in class 11 in the chapter of states of matter. So today we are going to start states of matter. Do you think so? No, it's solid state. What we'll learn in today's class, we'll learn about the definition of solid, characteristics of solid, and types of solid. How can we define solid? Solid is defined as a form of matter in which all constituent particles are close to each other and hence possesses a definite shape and definite volume. General characteristics of solid. Solid का क्या क्या general characteristics है? First one, solid cannot be compressed like gas due to its rigid nature. This is due to small intermolecular distance of separation between neighboring molecules. Also, solid cannot be poured like liquid because the position of the constituent particles, atoms or molecules cannot be changed. Thus, solids have fixed mass, volume, shape and density. Second one, the density of solid state is greater than the density of liquid state or gaseous state. Ice is an exception which has density lower than that of the liquid water. The density of mercury is very high. Third characteristics, solid are hard. Hardness is due to the presence of strong intermolecular force of attraction. These forces are stronger than those present in liquid state and gaseous state. Exceptions are sodium, potassium and phosphorus, which are soft and can cut with knife. Fourth characteristic, pure solids have characteristic melting points. Solid with strong intermolecular force of attraction have high melting point. Solids with weak intermolecular force of attraction have low melting points. For an example, diamond has very high melting point and helium has a very low melting point. Fifth point, in solid state, constituent particles, atoms or molecules exhibit vibratory motion. They oscillate about their mean position but do not have translatory motion and therefore remain stationary at one position. Classification of solid. Solids are classified into the following two types on the basis of the presence or absence of orderly arrangement of constituent particles. One is crystalline solid and another one is amorphous solid. What is crystalline solid? A crystalline solid is a homogeneous solid in which the constituent particles, atoms, ions, or molecule are arranged in definite repeating pattern. That means a crystal has a definite geometrical shape with flat faces and sharp edges. Some major distinctive features of crystalline solid are: firstly, crystalline solid have long range order in which a large number of small crystals repeats periodically over the entire crystal. Next, crystalline solid have an arrangement which maximizes the total intermolecular force of attraction. Next, the stability of solid crystal is due to the presence of the following forces. One is ionic force, second one is covalent force, third one is hydrogen bond, and fourth one is van der Waals force. Next, pure crystalline solid has sharp melting point. That is, it melts at one constant temperature. This is due to the presence of uniform orderly arrangement of the constituent particles. The most important point is that crystalline solids are anisotropic. That is, magnitude of some of the physical properties of crystalline solid such as refractive index, coefficient of thermal expansion, electrical and thermal conductivities, etc. is different in different direction within the crystal. For an example, in the crystal of silver iodide, the coefficient of thermal expansion is positive in one direction and negative in other direction. The phenomenon of anisotropy provides a strong evidence for the presence of orderly molecular arrangement in the crystal. This can be explained with the help of diagram in which a simple two-dimensional arrangement of two different kinds of atoms has been depicted. When a physical property is measured along the slanting line CD, it will be different from that measured in the direction of the vertical line AB, as line CD contains alternate type of atoms while line AB contains one type of atoms only. Crystalline solids are further classified into two types: isomorphous and polymorphous solid. Isomorphous solid, two or more substances having the same crystal structure are said to be isomorphous. Iso means same, morphous means form. This phenomenon is called isomorphism. The atomic ratio of the constituent atoms of the substance is same for the isomorphous substance, as given in the following table. NaCl and KCl have same atomic ratio, similar molecular formula, and similar chemical properties, but they have different crystal structures. Thus, NaCl and KCl are not isomorphous. On the other hand, polymorphous solid is a single substance that crystallizes in two or more forms under different conditions is called polymorphous solid, and the phenomenon is called polymorphism. Polymorphic forms are also called allotropic forms. For an example, graphite, fullerene, diamond all are allotropes of carbon, while rhombic sulfur, monoclinic sulfur are polymorphic forms of sulfur. Second type of solid state, amorphous solid. The substances that appear like solid but do not have well-developed perfectly ordered crystalline structure are called amorphous solid. That is, the substance whose constituent particles are not arranged in any regular arrangement. Now, features of amorphous solid. Firstly, amorphous solid have short range order. That is, amorphous solid do not have an orderly arrangement of the constituent particles. Even if such an arrangement is present, it is present up to a short distance. Thus, they have short range order. Secondly, amorphous substances do not have sharp melting point. They melt over a range of temperature. As the temperature increases, amorphous substances gradually soften and become less viscous and melt. Next, amorphous substances are supercooled liquids. They have fluid properties and float very slowly under gravity. Due to this, lower sides of the glass pane of window, photo frames, cupboards, and showcase become slightly thicker and upper ends become thinner. Thus, amorphous substances are not real solid, they are also called pseudo-solid. Amorphous solids are said to be isotropic as arrangement of building constituent is random and disordered. Hence, all directions are equal and therefore properties are same in all directions. You should know about that there is another kind of solid, polycrystalline solid. Some solids like aluminium, steel have structures between crystal and amorphous. These polycrystalline solids have large number of small crystals. Small crystals have regular arrangement of constituent units, but the crystals themselves are arranged in random manner. So where we use amorphous solid? Amorphous solid have many applications in our domestic life. As an example, amorphous silica is used in polyvoltaic cell. Glass is an amorphous solid which has very wide application in our life. Unbreakable glasses or inorganic glasses are also example of amorphous solid. They are used in fabrication of house and also in the laboratory glassware. So accumulate all the features of crystalline and amorphous solid as a difference below. Thank you for watching my videos. Wait still the next classes.